Welcome to the last lesson of Unit 2. We did parallel lines last time. We're going to do perpendicular lines this time, and you're going to see a lot of similarities and also one glaring difference, hopefully. So, just like yesterday, I want you to be able to identify perpendicular lines from characteristics in their equations. Last time it was parallel. Now we're looking at perpendicular characteristics and writing the equation of a line when given information about a perpendicular line. So we're going to graph both of these, and you can probably guess what's going to happen. So 2/3 x minus 5, I'll do that one in red. So minus 5 up to right 3. And I'm going to do multiple uses of the slope to get more points. So that was this one. And I'll do this one in blue. Negative 3 over 2x plus 1. So plus 1. Down 3, right 2. Down 3, right 2. And you can see that those intersect. That should make sense because the slopes are different. But perpendicular does not mean just intersecting, first of all. Okay, these lines are perpendicular. What makes them perpendicular, or what identifies them as perpendicular, is their slopes. Now, before I go any further, I want to talk about perpendicular. Perpendicular does not mean that intersecting. Intersecting lines are not necessarily perpendicular. Please note that. Write that down is what I'm saying. To be perpendicular, they have to meet at a 90-degree angle. It's a very specific characteristic. Okay. I'm not going to really test you on that right now, but I need you to understand that perpendicular lines are lines that meet at a 90-degree angle. Okay, so I'm going to go ahead and keep moving. I just talked about how perpendicular lines can be identified by their slope. So to be perpendicular slopes, lines must have both of these things true. They must have opposite and reciprocal. Slopes. So their slopes have to be both opposite and reciprocal, not one or the other, but both. Now, I used two bigger words there. Opposites are something like -3 and +3. Those would be opposites only. Or -1/2 and +1/2. Opposite in sign only. Reciprocals would be something like 3/5 and 5/3. They're flipped. Or 1/4 and -4. Okay, so the fraction is flipped. Okay, sorry, back up on this one, I'm getting ahead of myself. So 1/4, the reciprocal of 1/4 would be just 4 over 1, which would just be 4. Okay, examples of both would be what I messed up on there. Let's say I have a slope of 2/3. An example of opposite and reciprocal would be flip that fraction, so 3/2, and have the opposite sign. So the first one was positive, the second one would be negative. And then another example would be if I have a slope of -1/5, flipping that fraction would give me 5/1. It's already negative, so +5 would be the opposite and reciprocal. So before I clear all this, let's look at the equations that we just did. The slope of this first one was 2/3. The slope of the second one was -3/2. They are flipped, and one's positive, one's negative. These are perpendicular, like we showed with the graph. So now, without graphing, can you tell if two lines are perpendicular? Let's take a look. Probably noticing that these are very similar to what we just did, except the relationship is different. So the first one, oops. I'm going to subtract 4x from both sides. I'm going to get them both in slope-intercept form. Divide by 2, I get negative 2x. 8 divided by 2 is 4. So notice that the y-intercept really doesn't have anything to do with perpendicular. All I need to look at for perpendicular is their slopes. So negative 2, and the original one, or the one that was not original, the first one was 2. So 2 and negative 2. Does that fit the criteria of making perpendicular lines? No, it does not. Why not? Those are opposites only. They are not reciprocals. Okay. Next one. Transform the first one, subtract 5x, I get negative 2y equals negative 5x plus 8. Divide by negative 2. Negative 5 divided by negative 2 is 5 over 2. Positive. 8 divided by negative 2 is negative 4. So we're comparing negative 2/5 and 5 over 2. The slopes are not the same. They are negative 2/5 and positive 5 over 2. The y-intercepts are actually the same, but that does not matter. Are those opposites and reciprocal? Do they fit the criteria? Yes, they do. These are perpendicular. The slopes are opposite and reciprocal. Last one, subtract 6x, I get 8y equals negative 6x plus 40, divide by 8. Negative 6 divided by 8 is negative 3 over 4 if I reduce it. 40 divided by 8 is 5. So the slopes are negative 3/4 and negative 4/3. Are these perpendicular? Well, they are opposites. They're reciprocals of each other. However, they're both negative. So if they're both negative, they are not perpendicular. Okay. So, oops, go ahead and get rid of all that. And let's go down and do like we did yesterday. How do we write the equation of a line perpendicular to a given line that goes through the point given? So just like yesterday, we find the slope of the given line. Step 1, the same. Step 2, find the slope of the perpendicular line. This yesterday, step 2 was the one where it was like, this is a silly step because they're the exact same. They are not the same. You have to do something from step 1 to step 2. That's why we did it yesterday, because I knew you'd have to do this today. Once you've done that, you use the slope in step 2 to find the equation using the point. And then you want to write the equation. Again, in slope-intercept form if I ask you for it. So here we go. We'll do this first problem together. Find the slope of the given line. This one's set up to be pretty easy. So step 1, the slope of the given line was negative 4. Step 2. Okay. Big step here. What is the slope of the perpendicular line? Now I'm going to introduce a symbol real quick. It's an upside down T, it looks like. That's the symbol for perpendicular. So what I'm saying there is the slope M of the perpendicular line. So I need to take negative 4 and I need to flip it. So right now it's negative 4 over 1, right? Flip it, I get 1 over 4. And I need the opposite sign. So it was negative, it's going to be positive. So my slope here is 1/4. Okay, now it's exactly what we did yesterday. Y minus the y coordinate, 1/4 x minus the x coordinate. So that's y plus 3 equals 1/4 x minus 8. And I know I'm saying this over and over again, but I want you to hear me say it again. If it says what it says in this problem, you can stop right there. However, I'm going to keep going just to show you that you can. So y plus 3 equals 1/4 x minus 2. Subtract 3, I get my final equation of y equals 1/4 x minus 5. All right. And we're going to do it again on the back. Write the equation of the line perpendicular to that line that goes through that point. Well, the slope of the given line, I'm going to do this much quicker because you're probably getting the point here. You're seeing the pattern. So I got to do this one, I got to do a little work. I got to subtract x. So negative 5y equals negative x plus 20. Divide that by negative 5. I get y equals negative 1 divided by negative 5 is positive 1/5. So my slope of my given line is 1/5. Don't fall for the trap of saying, oh, I just did some work. That's the slope I'm using. No, it is not. That's the first step. The second step is I need the perpendicular slope. I like to flip the fraction first. So 1/5 becomes 5/1 and then do the opposite sign. So it's positive. It needs to be negative 5. That's the slope I'm using. And now third step, y minus the y coordinate, which is negative 9, equals negative 5, x minus the x coordinate, which is negative 2. So y plus 9 equals negative 5, x plus 2. And this time I actually am just going to leave it like that. Okay, just to show you that it is okay to do that. All right. Last one. You saw this in the last notes. You're seeing it again. I want the equation of the line perpendicular to that given line that goes through that point. So basically I want that line right there. All right, so let's go ahead and do it. First one, the slope of the given line. Count 1, 2, 3, 4, 5. 1, 2, 3. So up 5/3. Good idea maybe to count again just to make sure. Yep, 5/3. That's right. So the slope of the perpendicular line, 3/5. The first one was positive, so the second one has to be negative. The point that we have is -5, +6. So here we go. Y minus the y coordinate is -3/5 x minus the x coordinate. I'm going to go ahead and put this one in slope-intercept form. So first I'm going to do x plus 5. Distribute. I get y minus 6 equals -3/5 x. -3/5 times 5 is -3. And I'm going to add 6. Get y equals -3/5 x. -3 plus 6 is 3. And just to show you that this worked out correctly, I'm going to start from the given point and I'm going to use my slope of down 3, right 5, and show you, oh, look. That is the perpendicular line. Okay, that's it. That concludes Unit 2. You know what that means. We are coming up on test time. So we're going to have some time to work on these two, parallel, perpendicular, and some standard form, but it's coming up soon.